everyone. Today we will pass to our new chapter, sequences and functions. First of all, we'll learn what is a sequence, how to generate a sequence, how to find the terms in a sequence, and how to find the rule of a sequence. But first, let's remind what is a sequence. We know that the sequence is a list of numbers in a particular order, like 3, 5, 7, 9, 11, 13, and so on. If you analyze the relation between these numbers, we can see, or we can say, that the difference between them is 2. So 3 plus 2 is 5, plus 2 is 7, 7 plus 2 is 9, 9 plus 2 is 11, 11 plus 2 is 13, and so on. So we have some terms which compose the sequence, and we have a common difference between these terms. So let's write the common difference which make our term-to-term rule in our question is plus 2. On the terms, the first term, we denote the terms by using the letters A1. The first term is 3. The second term is 5. The third term is 7, and so on. Now, let's learn how to generate a sequence. Let's have a look on exercise 5 on page 216 of your book. We have to write down the first 5 terms of these sequences. The first term is given as 100, and the term-to-term rule is subtract 5. So the first term is 100, then from 100 I have to subtract 5, so the second term will be 95. From 95 I have to subtract 5, so the third term, will be 90. Again we have to subtract 5, 85, and the fifth term will be 80. And it can continue like this. So 100, 95, 90, 85, 80, and so on. Let's pass to B. The first term is 1, and the term-to-term rule is multiplied by 3. So the first term is given as 1, and to get the other 5 terms, we have to multiply each term with 3. So times 3, it will be 3. Times 3 is 9. Times 3 is 27, Times 3 is 81. And it can continue like this. Let's have a look on C. The fourth term is 11, and term-to-term rule is add 3. So in part C, it is given the fourth term, which is 11, and the term-to-term rule is add 3. So we can find what is the fifth term. It will be plus 3. It means 14, and to find the other ones we have to subtract from 11 3. So 11 minus 3 is 8. 8 minus 3 will be 5. 5 minus 3 will be 2. So these ones will be the terms of our sequences. In the same way, you can continue with the other ones, D, E, F, G, H, I. Let's have a look on example 5 found on your book. What is the 75th term in the sequence 2, 4, 6, 8, and so on? In the first example, we learned how to generate a sequence by using term-to-term rule. It means we found what is the rule for passing from one term to the other term. The second way of generating a sequence is by using position-to-term rule. So if we have a look on this table, we have the position, which means the number of the term, and the term. So the first position, which means the first term, is 2. The second term is 4. The third term is 6. The fourth term is 8, and it will continue so on. Now I'm looking not what is the difference between each term, but what is the relation between the position and the term. So the first position is 2. The second position is 4. The third one is 6. The fourth one is 8, which means that the position is double to give the term. So to find the 75th term, I just have to double the position 75, and the term will be 150. So the nth term, it means any term in this sequence, will be 2 times n. Let's have a look on example 6. What is the nth term in the sequence? It means how can we find any term in this sequence, or how can we find the rule of the sequence? It is given the sequence 2, 5, 8, 11. If we take the term-to-term rule, we can see that the difference between each term is 3. So this one will be related to the 3 times table. It means we have to deal with multiples of 3. Let's have a look in position term table. The first term is 2, the second one is 5, the third term is 8, the fourth term is 11. If we write the 3 times table, it means if we write the multiples of 3, we'll have 3, 6, 9, 12. If we compare that one with the terms, we'll see that the difference between each multiple of 3 with the term is -1. So we can write that the rule for this sequence is multiply with 3 and then subtract 1. So the nth term will be 3n minus 1. Another way for generating the position to term rule for a sequence will be given now. So let's compare it with exercise 6. What is the nth term in the sequence 2, 5, 8, 11? So we said that each of the number is a term, and we can name them as A1. It means the first term is 2, the second term is 5, the third term is 8, the fourth term is 11, the 50th term will be something, or an term will be something else. So to find the nth term means to find an, or what is the general rule for finding the terms in this sequence. To find this an, or the nth term, we need the difference between each term. The difference in this sequence is +3. So the common difference, which is denoted with D, is +3. To find an, or the nth term, we'll need the first term plus n minus 1 times the common difference. An will be equal to the first term in our sequence is 2 plus n minus 1 times the difference 3. An is 2 plus 3n minus 3. An is equal to 3n minus 1. So the position to term rule for this sequence is same as the one that we found by using the table on example 6, 3n minus 1. You can use which way is more easy for you. In the same way, please continue to solve exercises 14C on your book. Please feel free to contact with me if you have any problem.